Okay, so we are doing our 10-minute check-in, and as you can see, the white part has diffused into the cubes quite a lot. So in your data tables for all three, you're going to want to mark 10 minutes as the new time point. And we want to see how far in the white has diffused. And so if you actually measure it up from the edge to the pink, the diffusion in is about 0.5 centimeters. So 5 millimeters is the diffusion depth. So the white is about 5 millimeters in. Okay. So for all three tables now, you're going to be able to mark that the diffusion depth is 5 millimeters. And that means that when you are calculating the width, base, and height of the pink inside now, you're going to be taking off 5 from both ends, which means you're subtracting 10 millimeters from each of their measurements. An observation you might make about this one is that it started off totally fuchsia, right? This shape, but we also know that its height is only 10 millimeters. So if you were to diffuse 5 millimeters from the right and 5 millimeters from the left, it would meet together in the middle, and that would be 10 millimeters totally diffused. And therefore, we no longer see any fuchsia because 5 millimeters, 5 millimeters, and 10 millimeters, the whole thing has been diffused through already. So you can already kind of tell which one diffuses the fastest, right? When you talk about an original cell that is a bulky shape, an interesting shape that's a flat cell shape, or just the same volume of cell, but with a lot more surface area, okay? So while we know this one is done, and we'll do calculations for all three of them, we're gonna put the other two, at least, back into their, actually we'll put all three back, but you understand that the one that was the flat or different shape is already completely finished diffusing. Okay, so back in they go. And we're going to see in another 10 minutes how much further the diffusion has progressed. So let's do some calculations then, because we have a set of data to work with now. So when you have your 10-minute time point, our diffusion depth we decided and measured was 5 millimeters. Okay. This means that when you are doing your calculations for the volume of pink now, for your dimensions of a big cube, you're going to want to do the base, your new base. Sorry, let me decrease the size here. Your base is going to equal 30 minus 5, sorry, 30 millimeters minus 5 millimeters minus 5 millimeters, which equals 20 millimeters. Your width is pretty much the same. And then your height has the same amount diffused in and out. So we're going to have 27 millimeters minus 5 millimeters minus 5 millimeters, right? And that's because it's from the left and the right side. So this is going to end up being 17 millimeters. And so you should be able to use your base times your width times your height to calculate the volume of the pink. Now this is what's going in your calculation space down here, okay? So you're going to take this material, and again, this is at, this is going to actually be at 10 minutes, right? And we're going to have our calculations for our volume. So our volume is going to be 20 millimeters times 20 millimeters times 17 millimeters, which equals, let's see, We're all the way down to 6,800 millimeters cubed now. And before, the pink used to be a lot bigger, right? Now we want to also calculate the volume of white. So we know the original volume of the big cube equals 24,300 millimeters cubed. And we're going to subtract the pink to get the white border. So which means we're going to subtract the 6,800 millimeters cubed. And that's going to equal our, sorry, I wrote original volume. We know that the original volume is the 24. So we're going to want to calculate volume of white. And so we're going to take our original volume, our big pink cube volume, because that's actually the white border now, right? And we're going to subtract the pink that's left inside. So 24,300 minus 6,800. And that's going to equal the volume of white being 17,500 millimeters cubed. And we would be able to put that in for the volume of the pink. Over here, it's going to be 6,800 millimeters cubed. And we're going to have, over here, we're going to have 17,500 millimeters cubed. Now, when you do your calculations in the table for the small cubes, you're essentially going to be doing the small one, and then you're just going to be multiplying the volume by 4. Okay, so you would do the 5 millimeters in from each side of the small cubes, and then you're just going to multiply it by 4 to get your volume of pink. Multiply by 4 to get your volume of white. Okay, the calculations aren't any different. You're just working with these smaller dimensions where you're subtracting the 5 and the 5 from to get your volume times 4, and then subtract from the total volume times 4, and that's your volume of pink and volume of white. For the flat shape now, basically you're going to have this time point and this time point, and then you don't need to record any more data because it's already complete at 10 minutes. Okay, because the distance of white or the distance of diffusion at 5 millimeters is the exact same, right, for all 3 tables, but your volume of pink is now 0, and your volume of white is the total volume. Okay, so this initial volume that you calculated for the different shape is now your total volume of white. And so you'd be done with that 3rd data table, which is super nice. Okay, I'll check back in at the 20-minute mark, and we'll calculate some more for the big cube and the small cubes.